A little while ago, we talked about some properties of this thing called the logarithm, and we spent a lot of time talking about the natural logarithm ln. Let's revisit that and actually define the logarithm function. Okay? So remember, if we had y equals b to the x, then to solve for x, we use the logarithm of base b. So x would be log base b of x. Right? And here, b is still greater than 0, b is not 1. All our usual things here. Okay? Now remember, in particular, we had the special case. If y was e to the x, then x would be ln of y. Alright? So, we often want to talk about inverse functions. Okay? So, if we have the function f of x equals e to the x, sort of the inverse function is the function which we denote f to the minus 1 of x, and this is going to be ln of x. Or likewise, if we have the more generic exponential function, the inverse would be log base b of x. Right? And what does, inverse mean here? Well, it means, if we did f of f inverse of x, we get x, right? If we compose these functions, right? So maybe I'll even say in this case, this looks like e to the ln x equals x, okay? And if we did f inverse of f of x, this would be ln of e to the x. And again, that's also equal to x, because e and ln are designed to cancel each other out. Right? And we'd have the similar statement here for logarithms. So, as a function, what does log look like? Right? So, let's remind ourselves of the function 2 to the x. Right? If we have the function 2 to the x, okay, then remember we plotted some values here for that. We did like -2, -1, 0, 1, and 2. And if you remember from before, this is 1/4, 1/2, 1, 2, and 4. So the graph of this function ended up looking something like this. 3, 4. We have this exponential function here. This is the graph of 2 to the x. All right. When we take an inverse function, what it wants to do is this chart that we made here, it wants to take that and basically just flip it over. Right? So for the function here, let's call it g of x is log base 2 of x. All right? The chart for this is going to be the same chart, but we're going to do it upside down. Right? So we're going to have 1/4 up here. We'll have 1/2 up here. Not 0. 1, 2, and 4. And this just all goes backwards. All right? So let's try and sketch that out. All right? Again, I want to emphasize this chart right here is just this one, but upside down. And that's because the logarithm is supposed to be the inverse of the exponential function. They're just kind of undoing each other. Or they do the opposite things. All right, so if we graph this one, let's see. We'll have something that looks like this. 1, 2. 1, 2, 3, 4. All right. So if we plot all these points, now the way this works, kind of interesting. So this function here, this is the graph of log base 2 of x. Now, most of your logarithms are going to have this similar form. I, again, challenge you, though, if this number here is less than 1, see if you can figure out what the graph looks like based off of, say, the one we did before, 1/2 to the x. Anyway, so this logarithmic function here, it has this certain pattern here. And, you've probably heard the phrase exponential growth, which we will talk about a bit later. There's also this phrase called logarithmic growth, which is super quick at the start and then very, very slow. All right? So this is maybe something like the value of a car. Well, it would be logarithmic decay, not growth, but think of the value of a car depreciates super fast at first, and then it kind of, assuming it's not going to turn into a classic or anything, it kind of levels out in some way. Right? So some interesting features here is, remember how exponential functions had that horizontal asymptote? Well, log base b of x has a vertical asymptote at x equals 0. Right? That's a pretty interesting fact here. So it doesn't have any more horizontal asymptotes, because even though it looks like this function is leveling out here, it isn't. It actually keeps going all the way to infinity. It just takes forever to get there. It's one of the slowest growing functions out there. Okay? The domain of this. So the domain of the logarithm is going to be the range of an exponential function. And if you think about the exponential function, remember it could only output positive numbers? So that means the domain of a logarithm can only be positive numbers. However, the range, remember with an exponential function, we could plug anything into that domain. And the domain of the exponential function becomes the range of the logarithm. So that's minus infinity to infinity. Right? So hopefully that's a nice little intro to what the logarithm is, what its graph looks like. Again, I want to emphasize it's really meant to undo the exponential function. It's the inverse of the exponential function. So the key property here really is, the key thing to remember about logarithms really is this stuff up here. This is sort of the most important thing for logarithms. Right. So we'll talk about some properties of logarithms in the next video.